Hi, Vintage Stereo Buff back again. Today I'd like to show you a Proton D1200 power amp for home stereo. I bought this amp. This amp came out in 1986 and it was about $600 in 1986. It had what was called dynamic power on demand circuitry. What this mounts to is a two-stage power supply using a low voltage rail and a high voltage rail. It operates on a low voltage rail most of the time, unless it hits dynamic peaks where it operates off the high power circuit. The low power capacitors here are 22,000 microfarads. Two 22,000 microfarad capacitors at 63 volts, 85 degrees. And it runs on those most of the time, up to 100 watts RMS and higher. But then on peak demands, the power supply tracks the input signal and adjusts it accordingly and shifts on the right power supply. The high power supply here, it has 4 capacitors. Each one of these capacitors is 15,000 microfarads, 120 volt capacitors. There's 4 of those huge capacitors. What seems odd to me, these are 22,000 and these are 15,000, but these are a lot bigger physical size. I don't quite understand that. But at any rate, it seems to work quite well. I've never been able to use all the power from this amp. All of the speakers that I use are a minimum of 95 decibels sensitivity. So there I can get about 110 decibels with 32 watts. Some of my other speakers 104 decibels, and all I need is about 16 watts for 116. So amplifiers like this, I don't really get to really push them to see what they'll do. I've never seen the the 3 decibel light click on this thing, and I've never seen the 6 decibel light click. I've never been able to drive it hard at all. It was just too loud in my room. And a funny thing about this amp, it's so well built, but there's part of it that was built very crappily, in my opinion. And that's this. Several years ago, I had to fix this problem where my inputs come in from the back. The RCA connectors, the only thing that held the RCA connectors to the board was the 2 solder joints on each connector. First thing I learned in electronics years ago was a solder connection was a low resistance electrical connection and was not ever intended to be a mechanical fastener. So they kind of violated one of the first rules I ever learned about electronics right there. But I guess they know more than I do. At any rate, my point being, I had to fix it once. And at the time I fixed it, I was kind of still back in the boozing days, and I didn't get that one thing quite right, and I moved things around a lot, and eventually it wiggled the wire loose. And when it wiggled the wire loose, I had this hooked up to some test speakers one day. Luckily it was just some old junkers, but I hooked it up and I wiggled this wire back here hooking up the input, and when I did, I heard a very loud pop on the right channel. A little puff of smoke rolled up out of the amplifier, so I shut it all down. It pegged the power meter on the right side clear over to 800 watts. I immediately shut it off. I thought it was toast. But I took it off, and everything looks fine up here, but I could see what the problem was down there. I could see a little trace of smoke. But anyway, I turned it over, and I got inside, and I had to repair it and hook 2 new wires back in there and connected them so that wouldn't happen again. But what had happened when I punched it over to 800 watts, the smoke came from in here. You notice here, this black wire tape, it cooked. I don't know if you could see it from there, but one of these signal traces, this signal trace right here, see this wire, and hooks on into here and hooks onto here into this pot right here. It cooked the trace between here and here, and then between this side over to here, into here. And fortunately, I examined all of this and looked, and there are no other connections in between here and here, and there are no other connections in between here and here. So I was able just to solder this wire here, pigtail it off to here, and these 3 points here. And I hooked it back up, and it's worked fine ever since. And I hope that doesn't happen again. But here's an interesting thing. Look how many transistors there are here. There are C3519A, 1, 2, 3, 4. And over here, C3519A, 4 here. These are all the same. And over here, these 4 and these 4 are all the same, but they're a different number. They're A1386A. 4 of these and 4 of those. I'm not sure if all of these are output transistors. I guess they might be. 8 of each. That's a lot of output transistors. Or if maybe some of these transistors serve a different purpose. But I don't believe I don't think this is a switching power supply that would use transistors in the power supply like a car amplifier would. This is the power supply, and this I think is a little more like a traditional power supply, in that the AC goes in to the primary coil, and then the AC comes out of secondary coil, is rectified, and then stored in the capacitors, and then used by the power output transistors. But I don't think this has transistors in the power supply like a car stereo does. Now, some like the Carver magnetic field amplifier, it does use transistors in the power supply. It operates on a completely different principle, though. So we'll get off of that, and I can't hook it up and play it right now, but in a later video I will hook it up with the preamp and play it. Also, here's a spec sheet on this. It's kind of beat up. But the spec sheet reads, rated power 100 watts per channel. Dynamic power at 8 ohms, 4 ohms and 2 ohms. On a 200 microsecond duration duty, 500 millisecond duty cycle. So it's on 40% of the time, off 60. At 380 watts into 8 ohms, 500 watts into 4 ohms, 520 into 2 ohms, dynamic power. at a 100 microsecond duration, which is what the industry uses for home hi-fi things, is 450 at 8 ohms, 650 at 4 ohms, and 800 at 2 ohms. The IHF standard 20 microsecond duration, which is a kind of an old standard used since around the mid-60s, was 540 at 8, 1000 at 4 ohms, and 1500 at 2 ohms. Dynamic power. And it's a dynamic headroom of 6 decibels. Total harmonic cessation 0.02%, intermodulation 0.02, clipping power at 8 ohms, 110 into 8, 175 into 4 ohms, and 220 watts into 2 ohms. Damping factor greater than 150. Not too bad on damping factor, I've seen better. And that's about it for now. I'll make another video later of the preamp that goes with this, and have them hooked up and maybe play a few test tones just to give you an idea. Anyway, for now, out.